Guys, welcome to the next section of our studies on differentiation. Today we are mastering the chain rule of differentiation, and we have to put in mind what a chain is. When we talk about chain, what does it mean? Now, the chain rule, also known as function of a function. Let's understand the full concept of this particular rule. What we need to put in mind is such that in mathematics, when we talk about the chain of a function, it means that the function is being built in another function, which also means that the output of one function becomes the input of another function. So here, when a function y is equal to u power n, and u is another function of the form ax plus b, then we can say that the function y is composed of another function u, which means that u being the output of this function will now becomes the input of the function y. And if I want to differentiate y with respect to x directly with respect to x, then we apply the chain rule, which states that dy over dx is equal to dy over du. This time, u becomes the input, which is the independent variable, and y become dependent variable, times du over ds. This time, u becomes dependent variable, which is a function of x. So the chain rule simply means that if I want to change from y to x directly, then dy dx equal to dy du times du dx. Meaning if y is equal to ax plus b power n and u is equal to as plus b, which means that our du over dx will also be equal to a. So here we can write that if u represent the whole of as plus b, then y is also equal to u power n, which means our dy with respect to du will be equal to nu n minus 1. That is using the principles of differentiation, the rules of differentiation, the power rule. So here, by using the chain rule, which states that dy over ds is equal to dy du. What is dy du? It is nu n minus 1. Here is z. We have our nu n minus 1 times du dx, which gave us a, which means the general simplified rule is to differentiate function as we do for the power rule. So if I want to use the chain rule, I just have to differentiate the function as we do for the power rule of differentiation of the form s power n, and then multiply the results by the derivative of the expression in the bracket. So what this statement is saying is such that if I have y equal to ax plus b power n, and I want to differentiate using the chain rule, then what I need to do is dy dx is for me to apply the common rule of differentiation for the power rule. So here, it will be the n coming here, multiplying the whole of expression, then maintaining the whole of this function, which is the u, that is as plus b. Here is it. Then the power rule is saying that we have to subtract 1 from the exponent, then go into the bracket, look at the fraction that we have here, and differentiate the fraction. So when you differentiate the fraction, what are we going to get? We are going to get a. That is what the chain rule says. Now, let's work on an example. We have example 1. And for the example 1, we are supposed to differentiate y equal to x squared minus 3x all power 4. So in this case, if we are using the chain rule, it means we are going to let u be x squared minus 3x, which means that du divided by dx will be equal to 2x minus 3 using the rules of differentiation. We differentiate this expression u with respect to x. That is our answer. So if u represent the whole of this bracket, then y will also be equal to u power 4. And it means that the input and the output for this function, which is the u, become input for y. So dy du would now be equal to 4u power 3 using the power rule of differentiation. Then we write our chain rule, which says that dy over dx equal to dy over du times du over dx. So we just have to substitute them. So my dy dx is equal to dy du, which is 4u power 3, times the du dx, which is 2x minus 3. We just simplify this expression. 4 will multiply the whole of this expression. Then u power 3 is here. Remember, the u represents x squared minus 3x. So we substitute the u, which our dy over dx will be equal to 2x minus 3 bracket x squared minus 3x all power 3. So if you don't want to go through the tedious process of using this particular rule, as the statement said in our previous slide, that if you want to differentiate using chain rule, then our dy dx will be equal to, use the power rule of differentiation. So the 4 will be here. Then I will enter the bracket, differentiate what is in the bracket. When you differentiate it, we are going to end up with 2x minus 3. Here is it. Then maintain the same bracket, then subtract 1 from the power. This is very simple and interesting. Now, let's move to example 2, which we are supposed to differentiate y equal to square root of 4x minus 3. So the solution for this problem will be to let u be 4x minus 3, which states that du divided by dx will be equal to 4. So here, if we want to substitute the u as 4x minus 3, it means we need to differentiate y with respect to u. So whilst we have square root of u, dy over dx is the same as 1 over 2 u raised to the power negative 1 over 2 when you differentiate this. So here we apply the chain rule, which is dy over dx equal to dy du times du over dx. So my dy dx will be equal to 1 over 2u minus 1 over 2, which I will also multiply it by 4. So as you are saying here, we have dy dx equal to 4. So at the end of it all, we are going to have 2u minus 1 over 2, because 2 goes here 1 and 2 goes here 2. So when 2 multiply the whole of this expression, we are going to end up with 2 times 1 divided by u raised to the power 1 over 2, which will give us 2 divided by square root of u. So when you are applying the chain rule, so remember, u is 4x minus 3. Then we do substitute the u, and our final answer will be dy over dx equal to 2 divided by square root of 4x minus 3. So this is how we apply the chain rule. It is very simple. So let's move to example 3. So pause the video and differentiate y equal to 3 divided by 2x plus 5. Then match your results with our answer. So here, this becomes the solution. We are going to rewrite the function as y equal to 3, 2x plus 5 raised to the power negative 1. That is reciprocation. Then we differentiate using chain rule principle. What is going to happen? dy dx equal to, I will maintain my 3. Then bring the power across the equal sign like I am differentiating power rule. So I have here negative 1. Then I will maintain the bracket. So when you maintain the bracket, you are going to get 2x plus 5. It means you are not going to change the bracket. Then the power is negative 1. I also subtract negative 1 from the power. Then straightforward, my dy dx will be equal to minus 3, 2x plus 5 raised to the power minus 2. So that is how we differentiate it straightforward. Inwardly, you are applying the chain rule, but you are not passing through that complex principle. That is the complex steps that we were using to solve the previous example. So here, this one makes the work very simple. Just use the power rule principle. So as if you are differentiating the power expression of x power n. So the negative one will come here. Remember, you maintain the constant. Then maintain the fraction, the bracket, the expression. Then just subtract -1 from the exponent. Then we have our results in this form. So here, dy dx can also be written in this form: -3 times 1 over 2x plus 5 power 2. Remember, reciprocation. Then the final answer will be dy over dx equal to -3 divided by 2x plus 5 all squared. So that is how we differentiate using the chain rule principle. So here, let's also differentiate this particular expression. This is supposed to be example 4, not example 3, using the first mode of chain rule principle. Then here our solution will be in this form. We are going to rewrite the expression as y equal to x squared plus 1 all raised to the power -3. When we do that using the chain rule, the power will come here, that is -3 will be there, as we are dealing with power principle of differentiation. So here we have dy dx equal to, the -3 will be here. Then I will maintain the power. So in the expression here, that is the bracket. So I will maintain everything in the bracket, that is x squared plus 1. Then subtract 1 from the power. When I do that, I will end up with dy dx equal to -3 x squared plus 1 all raised to the power -4. So here, dy dx will be equal to -3 times 1 divided by x squared plus 1 raised to the power 4. So our simplified results will be dy dx equal to -3 divided by x squared plus 1 power 4. Now, these are practice questions for you to try your hands on them. Don't forget to subscribe to this particular channel to continue to receive the best of high school maths education. These questions are very challenging and they can help you to understand the concept of differentiation. And these are also likely questions on WASSCE examination. Thank you.